Hello, Year 8. Today we're going to be learning about speed and calculating speed. Speed is a special type of rate, but we use it so often that it's good to spend a whole lesson on calculating speed and also rearranging the formula to find time and distance as well. So if speed is given the letter S, and D is for distance and T is for time. There are three different formulas that you can see here in the box beside it, but we can use this triangle to help memorize the formula. To use it, you cover the letter that you want to find. So if I wanted to find the speed, I would cover up the speed and I would know that what is left is distance over time. So speed is equal to distance over time. Whereas if I wanted to know time, I would cover up the time letter and it would be distance over speed. And finally, if I wanted to know distance, I would cover up the distance, and because the speed and the time are next to each other, I would times them. It would be speed times time. So they are the formulas that you have here in the box. You need to know all three of them, or you can have the triangle on your study sheet to help you memorize those formulas. So question 1, we want to find the average speed of a car that is traveling 500 kilometers in 5 hours. So speed, I want to find the speed. The formula for speed, if I cover the S, is distance over time. So I'm going to write that here. Speed equals D over T for distance over time, so I don't have to write the full word out. Now, our car is traveling a distance of 500 kilometers and the time is the 5 hours. So I'm going to put those in my formula. The D is 500 kilometers and the time is 5 hours. And we've done questions like this before. To calculate that, we divide the numbers. So 500 over 5 is 100. And then the units are there on my fraction as well. So kilometers are on top, so it's kilometers per hour. The speed is 100 kilometers per hour. Part B says find the average speed again. So speed is going to be distance over time, same formula, of a jogger that travels 9 kilometers. So that 9 kilometers is going to be the D, but in 45 minutes, that is going to be the time, but the units of that aren't very good. We don't really do kilometers per minute. We would prefer to have kilometers per hour. So we would change the 45 minutes into hours by dividing it by 60. 45 divided by 60, that will now be in hours. So I'm going to use that in my formula. So subbing in, the distance was 9 kilometers and our time is 45 over 60 hours. Then we use our calculator to find that. So we go 9 over 45 over 60, which equals 12, and it's kilometers per hour. Okay, so that was finding speed, both of them. One of them I had to change my time units, but both of them were using the speed formula. Question 2, we're now going to be using the distance formula because both of them say find the distance, find the distance. The formula for distance, back up here, distance, if I cross that out, is the speed times the time. So, writing that down, distance is going to be speed times by time. And we want the distance travelled by a jogger jogging at 9 kilometres per hour, that's the speed. If he jogs for 0.8 of an hour, that's the time. Just make sure that the hours in my speed, so the unit of time in my speed, so that was hours, that this is also in hours because they need to match. And just a tip, in B they're not going to match, so I'm going to have to fix them up. But in this one they do, they're both in hours, so I can put those numbers straight into my formula. The speed is 9 times the time, which is 0.8. 9 times 0.8 is 7.2 kilometres. Not kilometres per hour, this is just a distance. and the distance is just the kilometres part. Part B, find the distance travelled by a car. So it's going to be distance equals speed times time again. If it's moving at 80 kilometres per hour, so that is the speed for 4 hours and 20 minutes, that is the time. However, because I have kilometres per hour, I need my time to be all in hours. I can't have 4 hours and 20 minutes. That doesn't work. So the 20 minutes part, I have to turn into hours. I have 4 full hours, and the 20, we divide it by 60, because there's 60 minutes in an hour. So it's 4 and 20 over 60. That would simplify to 1/3, 4 and 1/3 hours, but we don't have to worry about that. The calculator will simplify it for us after we put it in our formula. So now that that is right, we put this in. The speed is 80, and then we times it by the time, which we worked out was 4 and 20 over 60 hours. Typing that in, we have 80 times by, use the 3 boxes for 4 and 20 over 60, which equals, let's turn it to a decimal, 346 point, let's do 1 decimal place, so 0.7. And that will be, again, just measured in kilometres. Okay, over the page, we've done speed and we've done distance. So it makes sense that question 3 is about finding the time. So it says how long? How long is a time? And coming back here, our formula for time is going to be distance over speed. So let's write that down. Time equals distance over speed. So how long will it take Arne to travel 540 kilometres? So that is a distance. If his average speed is 75 kilometres per hour. So I've labelled my distance and my speed. Let's put them into the formula. The distance is 540 kilometres. Actually, I don't need to write the kilometres, but it's 540. And the speed is 75. 540 divided by 75 is 7.2. But the units of this will be time. Because my question had hours in my speed, this is going to be hours, 7.2 hours. Question 4, convert these speeds to metres per second. So we have Ian Thorpe in 2001, he swam the 400 metre swim in 3 minutes and 47.92 seconds. Okay, so it's speed. Speed is going to be equal to distance. Whoops, I wrote that the wrong way around. Let's start that again. Speed is equal to distance over time. The distance that he's travelling is the 400 metres that he's swimming. The time is the 3 minutes and 47.92 seconds, but I need it all to be in seconds because I want an answer in metres and seconds. So the minutes. For the 3 minutes, there is 60 seconds in each minute. So you go 3 times 60 would be how many seconds are there, but then you'd also add on the 47.92 seconds. So in total, that's 227.92 seconds that it takes him to swim this thing. So into our formula, the distance was 400 metres and the time in seconds was 227.92. Dividing those, we get 1.755. Let's just leave it at that. 1.755, and that would be in metres per second. Part B, Carl Lewis, he did the 100 metre sprint in 9.86 seconds. So the 100 metres is his distance, and the 9.86 seconds is a time. They are in the right units because I have metres and seconds. So we put this in our formula. Speed equals distance over time. The distance is 100. The time is 9.86. And dividing them, you get 10.14. Let's do 2 decimal places. Meters per second. Question 5. This would be a good kind of question to have at the end of a test where we have these 4 parts that all kind of build on each other. So first of all, it starts with Charlie is driving from Sydney to Newcastle. He travels the 264 kilometres in 3 hours. So that 264 kilometres is a distance and 3 hours is a time. Part A says, find his average speed, and remember speed is distance over time, in kilometres per hour. So that just means I need kilometres, which I have, and hours, which I have, and then I can put that into my formula. So 264 kilometres for the distance and 3 hours, so I can put the kilometres here and the 3 hours on the bottom. And when you divide them, he is travelling an average of 88 kilometres per hour. Part B says, convert this speed to metres per second. So we've done this before where we've changed our units in our rate. What we do is we change it back into a fraction, the 88 kilometres per hour. I'm going to have 88 kilometres in 1 hour. And I change each unit to the ones that I want. So I want the kilometres to be in metres. So to do that, I'm going to times it by 1,000 because that will turn it into metres. To turn hours into seconds, you have to times it by 60 to turn it into minutes and times it by 60 again. So that gives us on the top 8,8,0,0 meters over 1 times 60 times 60. You can type that in your calculator, but it's 3,600 seconds. Okay, dividing those numbers, 8,8,0,0 over 3,600, we get, turn it to a decimal, 24.4, and that will now be in meters per second. All right, part C. If Charlie has driven 5 hours at this speed, what distance would he have travelled? Now we're trying to find a distance, although it's spelt wrong. But anyway, if we're trying to find a distance, that will be equal to the speed times the time. The time that we have been given here is in hours. So that's going to be the t. So I have got 2 speeds. In part A, I have the speed in kilometres per hour. And in part B, I have it in metres per second. I don't want to use the one that's in seconds because I am working with hours. So I'm going to use the first one, the 88 kilometres per hour. That is going to be my speed because I want the units of time to match. I need them both to be in hours. So my speed is 88 kilometres per hour, and I'm timesing that by 5 hours, which gives 440, and the units for this will be the kilometres part of my speed, so kilometres. Part D, how long would it take? So when it says how long, that means time. Time is distance over speed. How long will it take in minutes for Charlie to travel 22 kilometres, that's a distance, if he were travelling at this speed? So because that distance is in kilometres, I'm going to use the 88 kilometres per hour from part A again as my speed. So distance is 22 kilometres and the speed is 88 kilometres per hour. When you divide them, 22 over 88, we get quite a small little number. We get 0.25 because that's going to be in hours, because my speed was in kilometers per hour. Remember that the question specifically said that I want my answer in minutes. So to change the hours into minutes, we're going to times by 60. So we go 0.25 times the 60, and it is going to be equal to 15 minutes. Okay, so that's the end of our lesson. Time for you to practice in your workbook on page 14 to 16.